Hello everybody, welcome to a new video from MCU Park. In this video, we will be unboxing and reviewing the RD6018 from Rident. This power supply has amazing power output of around 1 kW. It can deliver a maximum of 18 amps at any voltage between 60 and 1 volt. I got mine from Amazon for a very competitive price to eBay and AliExpress. I will leave the link in the description. I picked the complete set. It has the RD6018W module, the S800 case, and the 1 kW 68 volt power supply. The kit comes with everything you may require to start using it. However, you need to do some assembly. If you are not interested in the assembly, I will set chapters in the video description to go directly to the parts you are interested in. In the video, I will test if it can deliver the 18 amps, and test for the power supply output noise level, and will also test for the effect of high loads on the noise level. We will go through the menus and also show the iPhone application. With no further delay, let's get started. This is a box as received from Amazon. Inside is one box that contains all the modules. This is a controller box, and this is the S800 case. Inside the case, you can find all the wires required, as well as two types of screws, countersunk and flathead. The flathead will be used for mounting the power supply to the case, and the countersunk for everything else. This is a power supply. It looks so shiny. The controller is basically a buck converter. It takes the 68 volts from the power supply and reduces it to any selective volts between 60 and 1 volt. The power supply output voltage is okay. It is 68.3 volts. This is going to be our input voltage to the controller. Connecting the power supply output to the input socket of the control unit. Organizing cables, close the case, and we are done. It looks decent. The default screen shows the measured output voltage, current, and power in large size to the left. To the right, you can find the measured input voltage, the set voltage and current, and the overvoltage protection and overcurrent protection values. At the bottom, it shows the active memory location. We will go through this in details in a moment. The CV is the operation mode. It can be CV for constant voltage or CC for constant current. The tick mark is indicating the status of protection mode. It goes red if active. Last is the battery charging indicator. At the bottom right is the consumed watt-hour counter. It flips to show the temperature of the provided temperature sensor. Let's get into the menu pages. The wording of the menus is a bit off, but let's try to understand it. Take OK is for requiring a confirmation before activating any saved output settings. Take Out is for activating the settings as soon as you select its memory position. Boot Power is for activating the output immediately when you power on the device. Buzzer is used to silence the beep sound. Logo to select if you want to display the logo at the boot time. Languages. We have English and Chinese. Backlight is to set the brightness of the screen. To the right, you can activate the desired communication method, either Wi-Fi or serial communication if you wish to. Date and time can be set in here. The UpDR is the data refresh rate for the main screen measurement. We have 3 levels to select from. Last is the maximum output power, which actually depends on the power supply attached, and it's meant to protect the power supply. To change any of these settings, you need to press Enter first, then navigate using the arrow keys, and change the values using the rotary encoder knob. After finishing, just press on the encoder knob. To move to the next menu page, make sure you are not in the edit mode. If so, press on the encoder knob, then press on the right arrow. Here you can select the main page display style, either to see the values or graph it. On the graph style, you have the ability to change its scale by using the rotary encoder. On the third menu page, you can save your preferred setting combinations. You have up to 10 different positions. For changing the values, press Enter first to go to the edit mode. Use arrows to select the position. Use the VSET and iSet buttons for setting the voltage and current. Use the Shift before VSET or iSet for over voltage protection and over current protection settings. When done, press the encoder knob to exit the edit mode. By the way, the M0 is the default power on setting. The last menu page is the information page, where you can find all of your device hardware information as well as its temperature. For normal operation, you can set the required voltage, current, over voltage protection, and over current protection values the same way we did inside the memory position settings menu. Or, to use the saved settings, just press Shift, then the location number you want. To activate the output, press the on-off switch. This device has the ability to connect to an iPhone application via the Wi-Fi. I had several tries to get the application connected, and it was all unsuccessful. I found an issue with my internet provider, as they have the access point isolation feature active by default and not giving me any way to disable it for security reasons. So I decided to have an isolated Wi-Fi setup using an old router that I have. After that, it didn't work. Then I found that I have to enable the location services for the application on my iPhone, which is required to enable the app to send the Wi-Fi details to the controller. Finally, I got it to work and the device was successfully assigned an IP address. Rident has 2 applications on the App Store. I tried both of them, but only the RD Power application was able to connect to my device. The details you see on the application interface are pretty much the same like what you can see on the screen. However, You can see the values and the graph at the same time, with the ability to change the graph vertical scale and scroll horizontally to see previous recorded data. While you are connected to the application, the controller interface is locked and never get unlocked unless you are disconnected. You can control everything from the application as you do from the device, but you don't have a way to activate any of your saved presettings. I doubt I will use it frequently, but I think it might be a handy tool for whoever will use it for battery charging, as you can monitor the process without having to babysit it. Enjoy watching the time lapse, especially if you won't be able to configure the application for any reason. To test the power supply ability to deliver its maximum current, I will use my Rigol 3031A electronic load tester, which has the ability to draw up to 60 amps, but its maximum power is limited to 350 watts, so I will have to test at a low voltage, which I choose to be 10 volts. I will start the test at 1 amp current and gradually increase it till I reach the maximum of 18 amps. The power supply successfully passed this test. Next, I will increase the voltage to 30 volts and gradually increase the current till I reach the maximum power supported by the tester, and then leave it running for a while. This test also was successfully passed. Finally, I think this power supply will be able to deliver its rated values. If you are going to use this power supply in sensitive applications and you don't like to have voltage overshoots or high ripples, so this test is very important to you. I will be measuring and plotting the ripples on the output voltage. Also, I will change the load and see the effect on the output. At 20 volts with no load, the peak-to-peak voltage was fluctuating between 800 millivolts and around 400 millivolts. Those values are considerably high. It means when you are setting your output to 20 volts, you can sometimes see 20.5 volts. You will need to take this into consideration while connecting this power supply to sensitive equipment. When we add a load of 5 amp, the ripples increase till we reach 11 amps. The VPP reaches around 1.3 volts. That means at set voltage of 20 volts, your circuit may see as high as 20.7 volts and as low as 19.3 volts. Those are really high fluctuation values. To wrap it up, even this happens for a very short period of time, around 450 nanoseconds. It's all depending on your application and your circuit tolerance for voltage fluctuation. Let's not forget that those results are after the huge smoothing capacitors at the output, which also doesn't give you the chance to cut the power on your equipment immediately. Simply proceed with caution and keep that in mind. Thanks for watching till the very last minute. Wish you enjoyed the video and hope you learned something new. See you in the coming videos.